Hello everyone. Thank you for coming to the data track. My name is Klein. I'm the field CTO for data for Pivotal in EMEA. I don't want to spend too long talking about me. I've spent more years than I care to remember in IT now. I ran my own company for 12 years. After that, I found myself ended up working for CSC, large service company, system integrator. And I was fortunate enough to spend most of my time there working for one interesting UK government department out in the west of the country. And I got involved there with big data back in 2009. So for any of you that have been playing with Hadoop, you may know that back then we were talking about 0.1 something of Hadoop, alpha software. But it was interesting even then, and I got to stand up a number of very large clusters. Okay, and I'm sure Edward Snowden has told you all about them. The other thing I got to do while I was there was also to stand up an on-premise private cloud. And so I was in an interesting position because I got to see firsthand all of the problems you can have trying to run Hadoop at scale, and all of the problems you can run into with a private cloud if you're not careful. And in 2013, the opportunity to join Pivotal came up. And when I looked at what Pivotal was doing, they had the answers to all the problems that I'd had in my time at CSC. So I was very glad to be able to join them, which I did at the end of 2013. So nearly 3 years ago now. So enough about me. It's quite an exciting track, this one. So it's going to span lunch, as you know. So I'm going to do a quick intro, and then we're lucky to have with us today two of our product managers from the US. We've got Ivan Novick, who's the Green Plum product manager, and we've got Mike Stoltz, who is the Gemfire product manager. And we've also got Frank Siddy, who runs the data engineering team for Pivotal in EMEA. I'll do a quick overview, as it says here, of why data is important for your digital transformation agenda. And then we'll get some more detailed sessions from Ivan and Mike on two of the key products that can help you with your transformation agenda. Okay, and then we'll have a panel discussion. Now, the really cool thing is that after the afternoon session is finished, we're all going back in for the plenary session, and there's going to be a demonstration of a modern data architecture, cloud native, if you like, data architecture solution that will show you for real a lot of the concepts that we're going to talk about in our track. So it all comes together nicely. And the application that's making use of the data is going to be running in Cloud Foundry. So you get the whole loop closed. Okay, so I think you're going to find it very exciting. We do have a break for an hour at 1 o'clock, but I encourage you to be back here promptly at 2, so that we can carry on with what we have to do here before we go back to the plenary at around 3:30. Okay, so great software companies, okay, make use of big data to fundamentally change the way they interact with their customers and the experience that those customers get, okay. And what history tells us, from the recent years, is that this leads to entirely new business models, okay. So you're all familiar with these names, I guess. Uber, the world's largest taxi company, doesn't own a single taxi, doesn't employ, in the traditional sense of the word, a single driver. And yet, look at that market cap, okay? It's staggering, okay? AirBnB, the world's largest holiday company, holiday accommodation company, in terms of market cap. That's bigger than TUI, okay? Thompson Group, okay? It's huge. And they don't own a single property, nothing. Okay, so think about that from a business model. That is a fundamental change in the way business is being done, right? And you're all familiar with Netflix, and Tesla you know, a lot of people think Tesla's a car. I like to think of Tesla as a computer on wheels. And just to give you an example, there was the famous example of where, in the early days, some guy was cornering his Tesla at speed, and he damaged the batteries, which are all on the bottom of the car because the suspension went too low. So after doing an analysis, Tesla was able to see that they needed to raise the suspension of the car by 2 millimeters overnight, software patch down to the car. Next time anyone got into their Tesla, it was 2 millimeters higher off the road, and away they went. Now you think about any car manufacturer, other car manufacturer. If that happened, that's a billions of dollar recall to fix a problem like that, right? It's an entirely new business model, okay? So let's talk about how they're using data. So Uber and Netflix and Airbnb are all examples of disruptors. They're taking business away from other people, okay? You know, Netflix killed off Blockbuster, okay? Uber is, you know, so my colleagues, I mean, Ivan maybe can confirm, but I was told that in their first year of operation of Uber in San Francisco, the price of a yellow cab ride went down 60%. 60% in 1 year, okay? That's how much of a monopoly those guys had, right? Okay, and these people are disrupting that market. How are they doing this? Well, let's just talk. I just want to give you a couple of examples, but let's talk about Uber. So, I guess most people have used Uber, right? Well, you should try it. Okay, so Uber, those of us that have used it have got the app on our phone. Okay, we're used to that. But actually, Uber has two apps. There's one for us, and there's one for the driver. Now, so if you ever stop to think what happens when you get out of your ride, okay, so you've got your Uber ride and you've ended up at your destination. What does the driver do next? So if it was a traditional black cab driver, he would, based on how long he's been a cabbie, he would head off in a particular direction, hoping that he was going to get another ride based on his experience. Whereas, of course, Uber has captured every trip ever done anywhere in the country that or the city that you happen to be using Uber in. Okay, and they know, based on the time of day and where you are, what's the best direction to head in. Okay, and that's assuming they haven't actually got an immediate request in the vicinity for that driver, okay, to go and service. So the driver gets told where to go, okay? And there's an interesting YouTube video you can see where Uber used data science, which we'll talk about in a bit more, to improve the pickup rate by 1%. And that added tens of millions of dollars of business to Uber. Just a 1% increase in pickup rate. What about Netflix? So I guess most of us use Netflix. I do. It's a fact that over 75% of what people watch are based on Netflix recommendations. I mean, they have billions of viewing events, okay? They know that people who watch these types of programs would also like to watch this, and so they can make that recommendation. And with Airbnb, so I've not used Airbnb to actually rent any property, but if you do that, if you put some property up for rent, Airbnb will recommend a sale price for you. And experience tells them that you've got a much higher chance of letting your property if your price is within 5% of the guide price that they give you. Okay, and that's based on all of the rentals that have happened in your area. Okay, so how are they doing this? Well, all of these companies only use open source database technologies. Okay, and they use innovative technologies. They make use of cloud-native platforms, so they're all lucky. They've all entered, with the possible exception of Netflix, although they migrated out of their own data center into the cloud. They've all had the advantage of being able to go to a cloud-based infrastructure to give them the scale that they need. They make use of data microservices, and we'll talk briefly a little bit more about those today. And more importantly, and most importantly, they make use of machine learning. Okay, So they're using the data that they're capturing to train models. And it's a continuous process because people are watching all the time on Netflix, people are having journeys all the time on Uber, people are renting properties all the time on Airbnb, and so on and so on. And all that data is just being added. Now you contrast that with what happens in organizations today, where typically less than 5% of an organization's data ends up in their data warehouse, where it undergoes analytics. So if you're an organization that's doing that, how are you going to compete with someone who's got 100% of the data in their data warehouse? Okay, so the other interesting things these companies can do is that they can release new features in minutes with no downtime. They're able to do continuous delivery. And they can do this multiple times a day. The great figure everyone likes to quote is that somewhere in the Amazon ecosystem, something changes on average every 11 seconds. Okay, every 11 seconds. Okay, it's continuous. They're continuously trying to improve the user experience. They support a microservices architecture so that they can get the scale that they need. They update algorithms and predictive models continuously. That goes back to the point I made about machine learning. And they're continually asking lots of questions of their data. Once you've got all this data, there's no question that you can't ask. Okay, you just have to ask it. And they consume a wide variety and wide range of different data sources, including things like Twitter and Facebook and other social media forums. Data that they don't own, but that they can nevertheless consume. Okay. So, question was, can you do that? So let's have a look at analytics at the journey so far. So it started with descriptive analytics, which tells us what happened. We then moved on to diagnostic analytics, which tells us, well, why did that happen? Okay. So with those, we can get some insight. Okay. This is we're at hindsight here, and why did it happen? Insight. So now we can take some action. That's the traditional domain of data warehouses, where you've only got 5% of your data. Okay, but where you need to get to is up here. You need to be able to do predictive analytics. You need to be able to predict what will happen. Okay, and try and take an action based on that. And then the nirvana is what's called prescriptive analytics, where you want to try and make something happen. Okay, can you behave in such a way to make something happen? Okay, and there's a circle around there because this is where data science comes into play. Okay, so is data science important? So I think you're probably all familiar with the term digital native. That has been around for a long time now, but there's a new term that people are starting to talk about now called data native. So just to give you an example, a digital native, right, is interested in what they can do with technology. So a good example would be they expect to be able to program their thermostat like Nest, right? They can program it. But data natives are more interested in what technology can do for them. So they don't expect to program their thermostat. They want it to program itself based on, obviously not on day one, but after I keep changing the temperature, after a while it will know at that time of day he likes this temperature, when the temperature is only this, and do it for me, right? And that's a much more demanding audience, okay, that we're going to have to interface with going forward. So the question I've got for you guys, you might like to think about, is do you know the full value of your data and how to leverage it? So let's just look at that question a bit more. If you look at the value of data over time, so it turns out that here, if you're able to react very quickly within a short amount of time, your data is very valuable. Then as the time goes on, the data becomes less and less valuable. It kind of peaks out and then it starts to go up again. Okay, so the problem with the traditional data warehouse approach where you store less than 5% of your data is you end up around here. Maybe you've got a year. You haven't got the last 20 years of data or the last 10 years of data like Netflix has and like Uber has. And so you don't get the benefit of this value, okay? And it's understandable because in the past, it just wasn't cost effective to store that much data, but now it is. It's now cost effective to store every item of data that you can lay your hands on. And so it's this period here where the traditional data systems play, relational databases and the incumbent data warehouse providers. That's typically where they play. Big data plays over here, and products like Hawk and Greenplum can help you to leverage this value by allowing you to do analytics on that data. And then at the front end, we now call this fast data, and products like Gemfire, which is an in-memory data grid, can help you take advantage of and react very quickly up here. So I think Mike will cover some case studies here, and Ivan will cover some case studies over here to give you examples of what Pivotal customers have actually been doing at both of those ends of the data spectrum to capture, to create value. Okay, and this is where data science comes in. So if all you do with your data science is produce a pretty report, you're not going anywhere. You've got to operationalize those insights, okay? So here you have all the data you need to train a model, okay? And then you need to make that model available to the application so that you can react very quickly in real time. I'll give you a simple example. I don't think I'm going to pinch either of yours. So one of the UK telco providers has got to the point where, let's say the nearest mast that's covering this area has a fault. So the amount of service for that provider in this region is not adequate. And the service provider knows that Mike spends a lot more time on his phone than I do. We both get out our phones, and in real time, he gets his signal and I don't. Okay? They can deny me access because they've got limited bandwidth. They can do that in real time, okay? Because they've got all this data here that tells them who's the better customer, okay? And they're taking in real-time data from the mast that's saying, hey, I'm faulty. I can't take much capacity. And they're marrying those, the model is telling them what to do. Okay, just an example. Okay, so here's the challenge. This is this is a deliberately spaghetti-like diagram. I'm not going to talk you through it, but if you look inside any large enterprise today, this is what you will find. They've got every technology you can think of. Their apps have lots of point-to-point integrations. It's a mess. Okay, and these guys, right, have somehow got to be able to compete with your Netflixes and your Ubers and your Airbnbs and whoever's disrupting your environment, right? So down the left there's an example of all of the types of issues you find with this. Now, if you compare this with a modern cloud-native data architecture, look how much simpler this is, okay? So here, what's going on is that apps built using microservices can leverage whatever the best data store is right for that microservice. And then there are other data microservices that can capture the data that's held here and feed them into your data warehouse or your analytical models, whatever your data lake, whatever you want. And all of this is managed for you by the cloud-native platform. Okay, so look how much simpler as an architecture that is for an enterprise than the one we were looking at before. So this is where you really want to be able to get to. Okay. Conscious that I'm running on time, I'll just be as quick as I can. So I want to give you a sample of a real-world example that we did for a customer. So this is a picture of a mobile phone app for a company that is like UPS or FedEx in Middle East and Asia. Now, that company has some interesting problems because in a lot of countries that they operate in, there are no addresses. You know, your address would be, my house has got the red door behind the bakery. Okay, you know, it's not number so-and-so in street number such and such. Okay, and yet you still want to be able to get your delivery. Okay, so it's a challenge, right? And in some countries as well, for this customer, women are not allowed to answer the door. Okay, so if the man isn't home, you can't make the delivery. Okay, so it's quite a challenge. So what we did with this customer was, first of all, we took all of the data they had from how difficult or hard it was to deliver in particular areas, and then we started capturing all of their delivery data, you know, time of day, traffic, everything. And we built a model so that one of the things that it can do is tell the customer roughly what the estimated delivery time is, okay? And now, based on that, you can decide whether or not you can accept that delivery. So for example, in the country where a woman is not allowed to answer the door, if there's no man in the house in that time window, she can delay the delivery, okay? Simple example. And that time is fairly accurate. So they found by doing some market research that actually saying I'm going to arrive at 10:51 wasn't very helpful. A window was a much more predictive way of doing it. So if you look under the cover at how this is achieved, there's analytics going on. There's a model that's been trained that knows on that time of day in that city, based with all these other deliveries I've got to do on the way, that's my estimated time window for delivery, okay? We've built a model, we've trained it, it's continuously being updated. That model is continuously every journey that's made is fed back into the database. Every piece of data is stored. So this is a new way of working for this company, but now that they're in this way of working, they're storing everything, okay? Whereas in the past, we had to kind of transpose their paper records. You know, people signed at this time of day that they took their delivery. It's all deployed on a cloud-native platform, and it uses modern agile application development techniques. So here's an example where they're not just doing their analytics and putting up a nice presentation to the management. They are operationalizing their data science here, okay? That's the key message, in a way that's good for the customer. Okay, so I'll just summarize that briefly. So they've got data sources, lots of different data sources. They've got scale-out database, so they can store all of their data, and they've got the analytic capability so allows them to analyze as much data as they want, for which they can build and train a model. They can expose that model with an API to the applications that they can then develop. Okay, I'm just going to skip over this one. So this is a quote from one of our customers, Dave Bartlett at GE Aviation. I'll let you read it. But basically, you know, the magic happens when you take advantage of that data and bring that into your application. So you may have heard the term smart application mentioned this morning. This is what's meant by smart applications, okay? Where the application is giving the user a different experience based on what he's trying to do and all the information we have about that user and what other people have tried to do. So it's all about, in your digital transformation agenda, it's all about how you operationalize your insights, and your goal is to catch people or things in the act of doing something and try and influence the outcome, affect the outcome. That's your goal.